All right, people, this is Monday. You're responsible for 1 through 4. Starting with 1, we're going to decode this, the sum, answer to an addition problem of 3 and 8. Anytime we see and, we know that we're going to put those two numbers in parentheses, increased by 9. So increased means that we are going to increase it by 9. That means we're going to add. So the expression looks like 3 plus 8, because we need the sum of these two numbers, increased by 9. So 3 plus 8 equals 11, plus 9 equals 20. Number 2, we are modeling decimal multiplication, so we need to multiply 8/10. So we want all of this by 4/10. And the word by just basically means it's a cross up. So we are going to cross these over. And our answer in the model is everywhere we see that purple and green touch. And of course, algorithmically, we do this by multiplying the numbers as if we normally multiply them. So 8 times 4 is 32. And then we circle, circle, move it, move it. Number 3, we are using the area model to subtract fractions. So we would model 1, that's 4/5. 1, 2, 3, 4, 5. Number 2, side to side, 1/2. We are going to shade our models before we start doing any further partitioning. 4/5, and then we are going to further divide them, cross over the models, right, which will give us new equivalent fractions. So this is going to be, so both have 10. This is 5, which makes sense because 1/2 is equal to 5/10. And then here we're going to have 8, which makes sense because to turn this 5 to a 10, we would multiply that by 2. And if we did that on the bottom, we have to do it on top. And then we are ready to subtract because we have like denominator, so that would be 3/10. Number 4, we need to rewrite these in standard form. So we have 10 to the 5th power. Standard form just means it's a number. So 10 to the 5th power is a 1 with 1, 2, 3, 4, 5 zeros. 10 to the 2nd power is a 1 with 2 zeros, because that's what this exponent tells us. 10 to the 7th power means that our exponent tells us 7 zeros. So 1, 2, 3, 4, 5, 6, 7. We'll group them in stories. It's a million. All right. Number 5 is one that you guys did not have to do, but we are going to go over, and we will be looking at this in a few short weeks. We are converting 5 centimeters to however many millimeters. So we are going to start out by putting the number we started with in one blank. And because we are going from big to small, we will always use the operation of multiplication, and then we substitute the unit rate or the exchange. So how many millimeters are in 1 centimeter? And that's going to be so that would be 50. And then we are going from meters to kilometers, which kilo means 1,000. That means like a big 1,000. So we will be going from 400 meters divided by 1,000, which is going to give us 4/10 of a kilometer. And that's because if we're dividing this by 1,000, we are basically decreasing it by 1, 2, 3 powers of 10, which means we would start here and we would move it 1, 2, 3 times. And when we get to this, we will use place value charts and stuff like that to make all of this exponentially easier for you guys.